Welcome everyone to a quick overview of lesson 1.14 from calculus, which is infinite limits and vertical asymptotes. Essentially, we are going to be taking one and two-sided limits and getting the results of infinity, negative infinity, or zero. So let's look at that through this lens here. So we have the limit of this rational function as x approaches 2, but I notice that if I substitute in a 2, I just divide by 0. So I can't direct substitute. And I really can't do any simplification either. So what I'm going to do is I'm going to take the left-hand and right-hand side limits and see what happens. So we're going to take the limit as x approaches 2 from the left of x plus 1 over x minus 2. And 2 from the left, we can evaluate that as like 1.999. So let's do that. And if we do, 1.999 plus 1 is 2.999. 1.999 minus 2 would be negative 0.001. So let's think about trends. If we picked a closer number, what would happen? Because, again, this isn't the exact limit. We have to kind of think outside of the box a little bit for what the actual limit would be. And this is going to be a finite number. This is just going to get closer and closer to 3, where the denominator is just going to get smaller and smaller. So we're taking something that is essentially finite and dividing it by an infinitesimally small thing that's negative. This is going to trend towards negative infinity. So the left-hand side limit is equal to negative infinity. Let's see what happens with the right-hand side limit. If we get the same thing, then the overarching limit would be negative infinity. If we don't get negative infinity, then that limit does not exist. So we're going to take the limit as x approaches 2 from the right of x plus 1 over x minus 2. And for this we can use, let's say, 2.001. So again, if I plug that in, I will get 3.001 over, and that will be positive 0.001. So again, let's think about this and where it's going to trend. The closer numbers I plug into 2, the closer this is going to get to 3. So this is approaching 3. And the denominator is going to get smaller and smaller. So we're taking something that is essentially, again, finite and dividing it by an infinitesimally small positive number. This is going to trend towards positive infinity. Well, negative infinity and positive infinity are not the same. So this limit just simply does not exist. What if we have something like this one? It's a little sketchy because I have a squared here, so that might imply that something's going to happen. But let's see. Again, we're going to approach it the same way. We're going to take the left and the right-hand side limits and see what happens. So let's take the limit as x approaches 3 from the left. And that is essentially 2.999. So let's plug that in. 2.999 over, well, 2.99 minus 99. 2.999 minus 3 is negative 0.001, and we're squaring that. So we get what is essentially approaching 3, is 2.999, divided by an infinitesimally small number. Now the question is, what happens when you square something? Well, it becomes positive. So this is essentially the same as 0.001 being squared. And that's going to trend towards positive infinity. A little strange, a little strange. What happens if we approach from the other side? We approach from the right. Well, we'll get 3.001 over a positive 0.001 squared. We get something finite divided by something that's infinitesimally small. that's going to approach an infinity, and that's essentially the same as this because we're squaring a positive number. This is also going to track towards positive infinity. So this limit does exist, and it exists at positive infinity. So you have to be a little careful. Most of the time with these rational functions, they're probably not going to exist unless you see some sort of even power or something weird like that. But it's still good to check, and you can check by plugging in something that's really, really close and then thinking about where it's going to trend from there. That's it for 1.14. Good luck on your practice, and I'll see you in the next video.